The addition and subtraction of rational expressions with unlike denominators. So far, we have learned how to simplify rational expressions, add and subtract rational expressions, find the LCD or least common denominator, and how to write equivalent expressions. Now, we use all these skills to add and subtract fractions with unlike denominators, but in what order? Take a moment to arrange these in the correct order you think we would need to do in order to add and subtract fractions with unlike denominators. First, we would find the LCD. Next, we would rewrite the fractions so that they are equivalent and now have a new denominator. Then we would be able to add or subtract the rational expressions. And then finally, we would simplify the answer. Example 1, add or subtract. And so for A, we have the fraction 10x over x squared minus 9 minus the fraction 5 over x minus 3. And we said the first thing we need to do is to find the LCD, or least common denominator. To do that, we have to do some side work. We need to factor the denominators. The first denominator is x squared minus 9. Hopefully you notice that is a pattern, specifically the difference of squares, where we have a perfect square, a minus sign, and another perfect square, which will instantly factor into two binomials. And so this factors into x minus 3 and x plus 3. The other denominator is x minus 3 and cannot factor. So now we're going to use the chart in order to organize our information. The first denominator of x squared minus 9 we know factors into x minus 3 and x plus 3, which means it takes up two columns. The second denominator, x minus 3, does not factor, but we notice there is already a column for x minus 3's, so we place it in that column. In order to identify the LCD, we look at each of the columns. The first column represents x minus 3. The next column represents x plus 3. So therefore, your LCD is made up of x minus 3 and x plus 3. So that was the first step. Now that we found the LCD, we want to write it in equivalent fractions. So we currently know that these denominators in factored form would be made up of 10x over x minus 3 times x plus 3 minus the fraction 5 over x minus 3. And we found the common denominator to be x minus 3 x plus 3. So we need to see if we can rewrite these so that they have this new denominator. Looking at the first fraction, notice it already has the LCD, so there's no translator needed, meaning there's no change in that particular fraction. So the numerator will remain the same. The second fraction, notice, is made up of x minus 3, but we need it to have a denominator of x minus 3, x plus 3. So we do need a translator. In this case, what piece is missing? Hopefully you notice it needs the x plus 3. To maintain this fraction's value, we have to multiply by x plus 3 in the top and in the bottom. Now we are multiplying, so in the top, that 5 times x plus 3 needs to be distributed and becomes 5x plus 15. Now both fractions are written with the common denominator, so we now have equivalent expressions. Now that we have equivalent expressions, we're ready to add and subtract. Since these fractions have a common denominator, we can now write this as a single fraction, but make sure you use parentheses. It is the first numerator minus the second numerator. So those parentheses are a requirement. Don't forget them. Now we're focusing on the numerator. So on the side, we're going to do our side work. And I have 10x minus 5x plus 15. And we do order of operations, or gems, to help simplify the numerator. In front of the 10x, we notice there's nothing to be distributed, so those parentheses are not necessary. But in front of the 5x plus 15, we have that minus, which means it does need to be distributed. So there are some sign changes. We now have 10x minus 5x minus 15. Since we've done the multiplication, we're ready to combine like terms, which now gives us 5x minus 15. We have now simplified the numerator, so now let's put it back into a fraction. So the result of the subtraction of these two fractions is 5x minus 15 all over x minus 3 and x plus 3. Now we're on to the last step, which is to simplify. The only way to simplify a fraction is if they have common factors, which means it has to be in factored form. Well, on the side of our paper, we focus on the numerator. We have 5x minus 15, and we want to see, can this factor? Well, if you notice, 5 and 15 do have a 5 in common, so we do have a GCF, so we factor out a 5. We now have 5 times x minus 3. We rewrite the fraction in factored form, and now we look for any common factors that appear in the numerator and the denominator. Hopefully you notice x minus 3 appears in both places, so they reduce to a value of 1. There's no other common factors, so your final answer should be 5 all over x plus 3. And that was going through the 4 steps. Example B, we have the fraction 3x plus 4 all over x plus 2 quantity squared minus the fraction 2x minus 3 all over x squared minus 4. So again, the first step is to find the LCD. So on the side of our paper, we need to factor the denominators. The first denominator is x plus 2 quantity squared. Well, because it says quantity squared, that means we really have x plus 2 times x plus 2. The other denominator is x squared minus 4. Hopefully you notice that pattern of difference of squares. This instantly factors into x minus 2 and x plus 2. Now that both denominators are in factored form, we're ready to find the LCD by using the chart. X plus 2 quantity squared is actually made up of x plus 2 and x plus 2. X squared minus 4 is made up of x plus 2, but x minus 2 does not match the other columns, so we have to make a new one. Now that we have sorted all the factors, let's identify the columns. The first column represents x plus 2, the next column represents x plus 2, and the last column represents x minus 2. Therefore, our LCD is x plus 2, x plus 2, and x minus 2. Now that we have identified the LCD, we're ready to write our equivalent expressions. So we rewrite our current fractions, but with a factored denominator to see what we really have. And now we look at what we're trying to achieve. We know we want our common denominator to consist of an x plus 2, x plus 2, and an x minus 2. Looking at your first fraction, look at the pieces you have in the denominator and see if you have any missing pieces from the common denominator. And if you notice, you do have a missing piece, which that piece will be your translator. Our first fraction is missing the piece x minus 2. So therefore we have to multiply the numerator and the denominator by x minus 2. Well, in the top, that means we have x minus 2 times 3x plus 4. So on the side of our paper, we are going to work that out. X minus 2 times 3x plus 4 is a binomial times a binomial, so you will need to distribute. X times 3x, x times 4, negative 2 times 3x, negative 2 times 4, and you should get 3x squared plus 4x minus 6x minus 8. Since we've multiplied, we're now ready to add and subtract, and you do have like terms. Your result is 3x squared minus 2x minus 8, and that is your new numerator for your first fraction. Now looking at your second fraction, we currently have a denominator of x plus 2, x minus 2, but comparing that to our common denominator, what piece is missing? If you notice, the piece that we are missing is going to be our translator, and in this case, our translator is x plus 2 over x plus 2. So again, in the numerator, we are multiplying 2x minus 3 times x plus 2. We're going to do this on the side of our paper. Since this is a binomial times a binomial, we are going to distribute 2x times x, 2x times 2, negative 3 times x, negative 3 times 2, which should give you 2x squared plus 4x minus 3x minus 6. From here, we want to combine any like terms, and if you notice, your middle terms will combine, and you should find 2x squared plus x minus 6. And that is your new numerator. So now we've done our job. Both fractions have now been rewritten, maintaining the same value, but they now have a common denominator. Now that the two fractions are speaking the same language, now we're ready to actually do the addition or subtraction. Since they have the common denominator, you can merge the two fractions into a single fraction, but only as long as you use parentheses. It is the first numerator minus the entire second numerator. So those parentheses are not optional, they are required. Now our interest is in the numerator, and there's a lot going on. So on the side of our paper, we're going to do our order of operations. We're going to simplify it. So we have it just as it looks with the parentheses and all, and then now we look to try to simplify. Notice in front of the 3x squared minus 2x minus 8, we check there's nothing that needs to be distributed, so those parentheses are no longer necessary. But the second set of parentheses have a negative directly in front, which does need to be distributed, which means there are some sign changes. Once you've distributed that negative, we now want to combine any like terms. Notice we have x squares that can combine, we have x's that can combine, and we have constants, or plain numbers, that can combine. And your result should be x squared minus 3x minus 2. Now that we have simplified the numerator, let's see what our fraction really looks like. And so currently the result of subtracting these two fractions is x squared minus 3x minus 2 all over that common denominator of x plus 2, and x minus 2. So now that we have officially added or subtracted, we have an answer, but our answer is a fraction. And we all know anytime you have a fraction, you want it in reduced form. So now we're ready to simplify. In order to simplify, you have to find common factors, which means the numerator and denominator must be in factored form. Well, notice the denominator is already factored, so we need to focus on the numerator. On the side of our paper, we take the numerator, the x squared minus 3x minus 2, and we're going to try to factor. Since it is a trinomial, we're going to do the a times c method, so our first times last, which is 1 times negative 2, gives us a negative 2. We create our list of multiples, 1 times 2, and it's a pretty short list. But we notice the sign. The result was a negative 2, which means our values need to subtract, and they have to equal the middle term, which in this case is a negative 3. Well, from your list, 1 and 2, can those subtract to give you a 3 or a negative 3? No. And we have no other numbers from the list that could possibly work. So what does that mean? Well, that means this cannot factor. So which means x squared minus 3x minus 2 cannot be factored. Therefore, this is your final answer.